Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 93 in our incredible new tutorial series where you are learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. I am going to teach you a very accurate and a very easy way to calibrate all 9 sensors on your 9-axis IMU. Okay, in this class, we are using the GY-87 module, which has all 9 axes, the 3 accelerometers, the 3 gyros, and the 3 magnetometers. And that is the sensor module that we're going to use. But what I am going to teach you today on calibration, it would work for any 9-axis sensor module that you use. It's just if you use a different module, you're going to have to figure out on the Arduino side how to read those 9 channels. And then after that, everything else will be just like what I am showing you today. So let me get out of your way. And I'm going to ask you guys to go over to the most excellent www.toptechboy.com. I'm going to ask you guys to use this happy little search icon and search on something like Ultimate 9-Axis Program for easily and accurately calibrating blah, 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 something like that. Okay, again, we are using the GY-87 module, and this is the schematic of how we have it hooked up. And then last week, we had created a program that would measure all 9 of the sensor readings from the GY-87 module, okay? And so I need you to start where we left off last week, and I have that code here. I want you to go ahead and get my code because I did change the variable names from last week. Last week, we were just calling the variables like AX, AY, AZ, GX, GY, GZ, like that. But since we're going to be now expanding this to go from raw data to calibrated data, I wanted to go ahead and call those initial measurements raw values, okay? And then we come down here, we print raw values. So we're going to get that. And then I'm going to need you to fire up a fresh new Arduino IDE window, and you're going to paste that code. Again, it's almost identical to what we had last week. Let's just make sure this thing runs. And so I'm going to go ahead and download it, compile it and download it. Looking good, looking good. Okay. Now we are going to turn on the serial monitor here and look at that. It looks like we got 1, 2, 3, 4, 5, 6, 7, 8, 9 channels coming in. It looks like they're all alive, and so great. We are getting data. What kind of data? We're getting raw data. Now what we want to do is we want to take this raw data coming from the Arduino. We want to send it over to Python on your PC, and then we're going to have a Python program that will help us very easily and accurately calibrate this data. Now, what the Python program is going to do, it's going to bring this data in, and then you're going to be moving your sensor all around, and then that Python program is going to present you with visuals that will help you fine-tune the positions to get the most accurate calibration possible. And then the Python program will generate the calibration parameters for you. Okay, now very important, you can pull your hair out over this, but you have to turn the serial monitor off, because if the serial monitor on the Arduino IDE is running, it locks up that serial port, and then the Python program can't access that data. Okay, now what you're going to do is I'm going to have you go ahead and fire up a Python thonny window. You guys that are in this class, you already have thonny installed. If you're a drive-by shooter and just dropped into this class, you'll need to install thonny. When you install thonny on your PC, it will also install Python, so you will have everything you need. Okay, now today I'm going to do things a little different, something I've never done in 10 years of TopTechBoy.com. I'm actually going to give you my code. Why? Because in the last few lessons, I taught you Python. I taught you how to use pyqt5 to generate visuals. We stepped through a calibration, step by step, line by line, to calibrate the magnetometer. Well, I don't want to put you through a bunch of work. Okay, now let's do the accelerometer. Now let's do the gyro. I'm just going to give you my code because I want to talk more about calibration and not spend, it's a long program. It's, I think, like 800 lines of code, and it would take me 7 weeks to step you through the 800 lines of code. I stepped you through the magnetometer, and now, one time only, and never expected again, but I'm actually going to give you the code. So you're going to come back to the same page. We got the Arduino code here, and now you are going to copy this bad boy here. And then you're going to come over here and you are going to paste it. Now, again, for you drive-by shooters, you will need to install the library NumPy. You will need to install the library pyqt5, and you will need to install the library pyqtgraph, okay, to get this thing to run. Okay. So we already loaded the Arduino program. It is sending the 9 channels of data. Now let's run this bad boy and see what happens. Okay, didn't get an error so far. That's good. Now, what you're going to get is you're going to get an error, no calibration files found, please calibrate the sensors. Well, that makes sense. We haven't calibrated the sensors, so it doesn't have any calibration data, and it say, hey, you need to calibrate your sensor. So it's not really an error. It's just a notification of work that you need to do. So we'll say, okay, and then boom, we have this thing pop up. Okay, we have this thing pop up, and we're going to have to ignore this for right now. So we're going to move this window out of the way. Hopefully we're going to move this window out of the way, and we are going to focus on this window. And what this window has is it has my fancy new calibration. Now this looks a lot like what we did last week. Remember last week we were plotting the magnetometer data. Okay, right? We were plotting the magnetometer data last week. And so this week what we're plotting is we are plotting the accelerometer channels, we are plotting the magnetometer channels, and we are plotting the gyro channels. Okay, now let's just make sure things are live. So I'm going to pick this up. And okay, it looks like that I am getting live data on all the channels. That looks good. And the first thing we're going to do is we are going to calibrate the gyros. I wonder if this would look okay like this. No, I think I'll just leave you in full view like this. So the first thing we're going to do is we are going to calibrate the gyros. Now the gyros have an issue with drift, and so you see while I am sitting here perfectly still, this has got maybe a 0.5 degree error in the measurement of the angular velocity. You see the gyros are sitting still, but it thinks they're moving at about a 0.5 degree a second. The y-axis a little worse. It's measuring a 1 degree per second reading when it's sitting still. And really, you think 1 degree per second, that's moving along kind of fast. So that's a little bit of a bad error. And this one, about the same between half of a degree and 1 degree error. And so we're going to want to get rid of those. The way we get rid of them is we sit and we take 200 measurements. We take 200 measurements, we average those, and then we subtract that offset from the raw readings, and then we should have something that is much, much more stable. How do we do that? We're going to click Calibrate Gyro. Keep the device still for calibration. Important tip there. Okay, now the system looks like it's kind of locked up, but that's because it's off calibrating the gyro. It might take a minute or two. How do you know it's done? It'll probably pop something up and says it's done, and then your graphs will come back to life. Becomes very tense here as we're waiting. Okay, it's got the offsets. You see the error in the x-axis was 2 degrees per second, 1 degree per second, and about 0.6 degrees per second. So you see, I'm glad we got rid of those. Now when you come in, now we are showing here calibrated data, and you can see that they're all sitting at 0 now, and that is what we want, and that is very good. Now, this is just a review for you guys in the class at this point, but the secret to get the most accurate calibration possible, what you need to do is you've got to find the exact maximum and minimum of each of these 6 channels. You have to, for the x-axis accelerometer, you got to find the maximum position, the maximum x value, and the minimum x value. You have to find those maximums and minimum for the 3 accelerometers and the 3 magnetometers. All right. And if you're just doing that by looking at 9 numbers flying by, it's very hard to tell if you are doing it correctly or not, if you're really finding that perfect point. So what I showed you last week is what you do is you plot on acceleration. Let's say you plot the x-axis versus the y-axis. So this is the x-axis sensor, its value, and this is the y-axis sensor, its value. The Y sensor and the X sensor, and you just plot Y versus X. And if you rotate the sensor through the XY plane, if you rotate the sensor in the XY plane, you should get a perfect circle. And what you want to do is at the top, bottom, left, and right, you want to really tweak it to make sure that you're finding that maximum and minimum. How can you tell? Well, you're looking at it against a circle, and that circle will help guide you to get those perfect maximum and minimum points. Does that sound good? Okay, I hope it does. So what I'm going to do now is when you're doing the accelerometer, you got to make sure that you don't shake it, because we're looking for orientation data. And if you generate some acceleration, then you're going to get some values that are not the true maximum and minimum values, okay? So what I'm going to do is I'm going to need you to watch this red graph. And what I'm going to do is I'm going to go ahead and I'm going to say calibrate the accelerometer. So I click that, and it says rotate device in all directions, a full 3D rotation to capture the minimum and maximum values for all axes, okay? Good. So I'm going to say okay. Now I'm going to carefully pick this up, and what I'm going to do is I'm going to look at the XY axis, right? The XY axis. And now what I'm going to do is very carefully rotate. And do you see? Let's see. Yeah, that's good. So now I'm going to very carefully rotate, but I got a little bit of acceleration right here when I was picking this thing up. So I'm going to stop the calibration, and then I'm going to calibrate again. I'm going to start again, okay? And then here we go. Okay, so now I'm going to very carefully this time rotate it about the XY axis. Now I want to very carefully look at the 4 corners. So the 4 corners of a circle. So this is the left, that looks good. And now I'm going to be rotating it on around. So do you see that red graph is generating? That red graph is generating a circle. And I'm trying to be very careful up here at the top. And you see, I think that has got the maximum value. And now we're going to come on around. And again, as I reach this horizontal position, I want to really tweak it there to find the maximum value. And then I'm going to come on up like this. Now we're here, we want to make sure that we very carefully are getting the minimum value. We're going to come on around, and we have made a beautiful circle. And the software has captured those maximum and minimum values of X and those maximum and minimum values of Y. Now what we're going to do is we are going to swing it through the XZ plane. We're going to rotate it in X and Z. And so that will make the XZ, the blue, generate a circle. So we're going to be coming around here. I'm up here at the top. I want to really try to get that best value. And then we're going to come on around. And now over here to the right, very slowly looking for that perfect circle. And then we're going to come on down. Now again, that's the critical point for us to be looking at. And then we're going to come on around. So that is good. Now for the green, we've got to drive the bus. Okay, so this, we're going to rotate it in the YZ plane. Okay. Which one did I not do? Okay, this is the one that I didn't do. This is the one that I need to do. Okay, and so we've got the maximum there, and we're coming on around. Coming on around. Okay, so we got three really, really good circles here. All right, and so now I'm going to say stop calibration. Okay, so now the accelerometer should be calibrated. But I think we can check that, because now what do we want? I think I want all my values between +1 and -1. And so if I come here and I'm rotating, no, it's still showing the raw data there on that. Okay, but it did get those maximum and minimums that we wanted. So the gyro is calibrated, and now what we have to do is we have to calibrate the magnetometer. Now for the accelerometer, it was very important, like if we were rotating, to keep the thing flat. But you see, we don't get the best values on the best values on the magnetometer by holding it flat. Why? Because the Earth's magnetic vector is not coming in at horizontal. The Earth's magnetic vector is either coming into the Earth at some angle, or it is coming out of the Earth at some angle. And let's see if I can find that real quick. It's called the inclination. And I'll kind of show you these graphs. So you'll get a better idea of what we are trying to do. You'll get a better idea of what we are trying to do. So I'm going to search on magnetic inclination on Wikipedia. And it's got a good global map showing you what the inclinations are. And I hope this is it. So I'll click here. Okay. And there is the map, so I will zoom in on that map. Okay, so where on Earth is the magnetic vector horizontal? The magnetic vector is horizontal at this green line, okay? And that would be like in South America, it would be here going through Africa, okay? But where I am is right about here. And that would be about -23. I'm at an inclination of about -23 degrees. So where I am, the Earth's magnetic vector is not coming horizontal. It is coming down into the earth. Now, let's say you were in Dallas up here. You have a positive inclination, meaning that the magnetic vector is coming out of the earth and it comes out at a 60-degree angle. So your magnetic vector is not like this. Your magnetic vector is not like this. Your magnetic vector is like this. What does that mean? If I rotate like this, I am not going to see the maximum. I need to, if this is north, I need to elevate it by 20 degrees when I'm pointing north. If you were in Dallas, you would need to tilt it at 60 degrees like this. Now, when you look at the graphics of the circle, it will help you find that right tilt, but you can't just do it like this. You need to tilt at your inclination. And when we get over there, I will, you'll have some real help in doing this when we get over there. Okay. So the other thing is you have to leave it like that, and then you have to rotate it along that tilt. So you see here, with this being north, as I rotate it, here now the Y is pointing, or no, this is the X is pointing north. Now that's 20 degrees. Now that's 20 degrees. And so you've got to kind of leave it tilted, and you have to rotate it around that tilted plane. Now, I hope this isn't confusing what I'm saying, because when we look at the graphic, it's going to help us find that point. Okay, it's going to help us find that point. So we are ready to give it a try at calibrating the magnetometer. And so you can kind of get an idea by looking on this map about what angle you should be tilted to get your best calibration. Okay, so let's come back over to our Thonny program, and hopefully this thing is still running. Hopefully. Okay, let's see. Yeah, it is still alive. So now, which one? Okay, now what I'm going to be doing is I'm going to be rotating around, let's see, what do I want to do? I want to rotate around the XY. So you're going to be looking at this light blue. Okay, now watch this. If I hold it flat, do you see the light blue when it's flat? Oh, wow, I think I'm getting a great circle, right? But the problem is I need to be tilted. For me, this way is north. I need to be tilted at 20 degrees. And then when I rotate around 20 degrees, you see that I am getting a much bigger circle. Now this is pointed north, and I'm tilted at 20 degrees. And then I come here, coming on around, and now I have that side. And now do you see how I'm tilted 20 degrees up at the top? Okay, we're going to do it like that. Okay, I did not actually yet click calibrate magnetometer, and so let's go ahead and do that. So you see, I'm going to start like this. Okay, calibrate magnetometer. It says rotate in a figure 8. No, do exactly what I'm showing. So I am tilted by my inclination. You are looking at the light blue, and I kind of already done this. Okay, so right there, I'm getting that. And then I'm coming on around. And you're not really seeing it too perfectly because I'd already made that blue circle. Okay, and so that is good. Now, this is pointing north. This is pointing north. Now look at the purple. Okay. Now I've got to play with it here to make sure that I'm getting the maximum top on the purple that I can. And now I'm coming on around. This has to continue pointing north, because watch, if I don't continue to point north, I'm doing strange things with that circle. Okay, so with it pointing north, now making sure, coming on around. And now I've rotated through the YZ plane. Now I need to rotate about the XZ plane. And so for that one, I now have this pointed north, this way pointed north. You're looking at the yellow curve. And man, I'm afraid that my words are going to be confusing you. But if you just look at your circle that you're creating and you're trying to make the biggest circle that you can, okay? The biggest circle that you can. So coming on around, working it there, working it down there. And you've got to keep track of what axis you're working on, and you got to make sure that you leave it pointed north and then rotate it as my long edge is pointing north. Okay, I think we have that calibrated, and so now I'm going to say stop calibration. It's giving me the calibration parameters, and now that I have all this calibrated, I'm going to go ahead and say save calibration. Okay, now with that saved, okay, with that saved, I am not sure on my accelerometer why it isn't kind of using the calibrated data, but I'm going to go ahead and stop this. And then this time when I run it, it should find those calibration files, okay? Okay, now again, we're going to get rid of this for right now. Okay, now it is showing me on the accelerometer the calibrated values. What should the accelerometer be? Between plus and minus 1, plus and minus 1. Okay, and same thing on the magnetometer. So now I'm not calibrating, but I'm kind of checking my calibration. And so what we're going to do is we are going to rotate. Let's see, which one do I want to do? Yeah, I'm going to do this one. So you're looking at the red curve. No, you're looking at the green curve. Okay. You see I got some not perfect data points. And that is still, I guess this is showing calibration for you know, for the plus and minus the plus and minus 10, which is, it's not showing it normalized to 1. But that's okay because you can see there that is looking good. Okay, and now let's look at the magnetometer. And so you see that blue, I'm going exactly to 1, and then I'm going exactly to 0, and then I'm going exactly to minus 1, and then I'm coming over to plus 1. Okay, so you see the fact that I'm getting those circles is showing me that this thing is calibrated. Again, I'm making perfect circles and I am getting 0 readings on the gyros. And so that is really, really good. Now, what I want you to do is, okay, I'll show you this in a minute, but what I've actually got to make things even simpler, I generate a function here. If you say generate code, let me go ahead and do that. We just won't do anything with it yet, but I'm going to say generate the code. Okay, and it says Arduino calibration function saved in call data.txt. Okay, now if we come over here and we look at our files and we will view the files, you see this, let me, maybe I need to refresh. Okay, there it is, yeah. This caldata.txt, let's open that up. And what you see is this generated a calibration function with your calibration numbers. It generated a calibration function with your calibration numbers. And then it even applies those calibration numbers to, like here, it applies those numbers to get the calibrated accelerometer, gyro, and magnetometer values. And so now all you got to do is take this function, that not only does the calibration, it has your specific calibration parameters, and we got to go add that to our Arduino program. But I don't want to do that just yet. I want to come over here, and now this thing should be working because I have calibrated data. And so let me come over here, and then what I'm going to do is I'm going to come over and I'm going to point this north. And you see, as I am pointing this north, no, that's not. Where's the view? This is the view that you need. So you see, as I have my sensor pointed north, my compass is showing north. Now watch this. I can come up and I can pitch, right? That this is the front of the airplane is flying which direction? North. And as I do this, watch this graph here. Watch this, okay? As I am tilting up, the airplane's going up, pointing towards the sky. I am now climbing at 30 degrees. Okay, let's put it down. I'm going down, and now I am pointing down 30 degrees. And so I've got kind of like a heads-up display here for an airplane. 30 degrees towards the sky, 30 degrees towards the ground. We can rotate east, okay? We can start flying west. Okay, now we can also do the roll. And so if you look here, you have to think of this like the airplane wing. And so I'm going to roll to the left. I'm going to roll to the left, and do you see how it shows that roll to 30 degrees? I'm going to roll this way to 30 degrees, and I can come up and I can come down, and I can rotate and I can rotate, and then I can fly in different directions. And so at this point, this is just pretty darn exciting to me. This is just pretty darn exciting to me. Now, what you're going to ask is, what is this? What is this thing here? This is a graphic that shows you, this is the graphic that shows you your magnetic vector. Now this red is north, okay, so you can see here that I am pointing north. Okay, I am pointing north there. But you see, this is north, and then here on the graph, it's like that is north. And so I'm just going to press the mouse and I'm going to rotate this way. And now north on the graph kind of matches north in the real world. Now, why is that red line coming down like this? That is showing me the magnetic vector, and my magnetic vector is not horizontal. So what I can do is, if I want to find my inclination, I just start tilting this until that red comes down and is exactly like that. Okay, it is exactly like that. So I'm going to come out here so maybe you can see it better. So you see, I need to point it north. I need to line up with the red. Okay, now I want to get my inclination. And so as I'm pointing north, I bring it down, and then right there, boom, I've got it. Okay, now I can also come over here, and then this would be like I am pointing east. Okay, I am pointing east. I think, yeah, there it is. I'm getting a little data hanging up there. I'm going to hit the reset here. Sometimes if the data is coming in too quickly, okay, so now I'm pointing east, and again, I can line that vector up, and it's kind of measuring, it is measuring that inclination. Now, if you are in Dallas, yours is not going to look like this. Yours is probably going to be down here or something like this if you look at that graph. So what does this do? This allows me, as I am calibrating the magnetometer, if I watch this, I want to hold it like that. You see, I've got the right tilt. Now I want to rotate it and keep that vector flat. Do you see how I'm trying to keep my magnetic vector flat as I go around. Okay, how do you like that? I think that is just pretty extremely cool. This is just really pretty extremely cool that you can actually watch that magnetic vector as you are moving around. Even like you can go upside down, you can move it every which way, and it shows you the magnetic vector as it is coming in, and that I like to, when I'm doing a calibration, I like to kind of watch that because it allows me to make sure that I am rotating in the correct plane. Does that sound good? Okay, so now what we're going to do is we're going to come over here, and I now have this code that has been generated. And so I think I'll come and remember we saved the calibration, we generated the code, and so now I'm going to say stop. Now I'm going to get this code that we just generated, I'm going to copy it, and now we're going to go back to the Arduino side. Okay, and remember how I came up with these new values here. So what I'm going to do is just after the void setup, I'm going to come in and I'm going to paste that function like that. Okay, so these are my calibration numbers for my particular sensor. And then if I call this function, what it is going to do, let me look at that again. Oh, I didn't get all the code. Whew, that scared me. Okay, so you got to make sure that you're copying and pasting all of the code. And so I looked over there. I thought, this isn't what I want. So you see, you got to come all the way down. I'd gotten the calibration numbers, but I hadn't gotten the calculation. So you get that whole function, and then you come back over here. I'm going to get rid of what I just pasted in. Okay, and so we're after the void setup. We're going to paste this in. Right now, when I have put this function in here, I have new values. The new values are not the raw values. These are the calibrated values. So I got to declare those variables. So up here where I declared all of these, I'm going to take this, copy it, paste it, and then here I've got to declare my calibrated variables like that, cal. Okay, so I will copy, and then I will paste, 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 paste. Okay, now similarly, I don't want to print my raw data down here. I want to print my calibrated data. Okay, so then the same thing, I want to print my calibrated data. Maybe I should have had Python just write the whole program, huh? That'd be an interesting homework assignment to do. Okay, so now I'm printing my calibrated data, and I've killed the Python program, so that should all be okay. Now, very important, if you want to calibrate again, don't run this new program, run the old program, because you don't want to send calibrated data and do a calibration on top of a calibration. So use the old program to feed the Python program. And now this one over here, just on the Arduino side, this should give us 9 channels all calibrated. So let's see what happens. That scared me when I got over here and I didn't have all my code, because I hope I was hoping it was not an error in my 700 or 800 lines of code. Okay, so now let's turn this on. Okay, and this is not. Okay, one other thing. So what I got to do is I've got to call. I put the function in, but I never called it. So I'm going to copy that, and then I'm going to come down here. So here, I've made all my measurements. You'll measure, 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 measure. But then right here, what I'm going to want to do is I'm going to want to call that function that will calibrate all of those last readings. Yeah, I'm using global variables because it gets very tedious to try to pass parameters in and out of that function. And because this is a small program, the easiest thing is to just make them all global variables. Okay, so now let's run this thing again. Who's your friend, Mr. Semicolon? All right. I think it's going to be good this time. Okay, so now let's turn this on. Turn the serial monitor on. Okay, boom. Look at this. The X is reading 0 exactly. Why? Because we calibrated the sensor. So we're getting a perfect 0 reading in X. This is sitting flat. The magnetic or the gravitational vector is coming straight down. So the x-axis accelerometer is reading 0. The y-axis accelerometer is reading right at 0. Okay, and then the z-axis is reading 1 because it's seeing the full brunt of the gravitational vector. Now this next one is the gyro, and you can see it's reading between 0 and 0.1 degrees per second. And so instead of having it be 2 degrees per second, I brought the drift component down to a fraction of a degree per second, okay, 0.1 degree per second. So that's really good. Same thing, this is the Y gyro, the Z gyro, and now on the magnetometer, this is the X magnetometer. Now I'm going to go ahead and point it north, and as I point it north here, you notice that I'm not at 1. As I point it north here, I'm not at 1. Why? The magnetic vector is coming like this. So if you look at this number, I'm going to have to tilt this. I'm going to have to tilt this some amount to get that full value. Similarly, if I come over here, and now you're looking at this number, it's not going to read 1 when it's flat. I'm going to have to put the inclination on it for it to read 1. Now, as we are calculating magnetic north, you don't have to worry about what the inclination is. It's just when you calibrate it, you've got to tilt it at the inclination and rotate about that. And so again, like if I look at this number here, I'm pointing north, it's reading 0.85, and I've got to tilt it. I've got to tilt it here to get it up to 1. I've got to tilt it to get it up to 1. Okay, so now we have everything calibrated, and we have a cool program that allows us to play with our sensors, figure out what's going on with them, check our calibration. Okay, we can check our calibration now by playing with it. We can check our calibration by playing with it after we've calibrated, because if I go back to that thonny program and I send just the raw numbers again, then the first thing it's going to do is it's going to load the calibration from the last time. It's going to start with those calibrated numbers you did last time, and then you can play with the thing about looking at your compass and looking at your pitch and looking at your roll. Okay, now that is pretty darn cool. So what is your homework assignment for next week? Now you have got good calibrated data for the accelerometers, for the gyro, and for the magnetometer. Now for next week, what I want you to do is I want you to take this program and I want you to calculate roll, pitch, and yaw. Okay, for the roll and the pitch, you're going to apply a complementary filter on to fuse the calibrated data coming from the accelerometers in the gyro. I showed you how to do the complementary filter, but now you're just doing that filter with better calibrated raw numbers. Okay, you take the raw numbers, you calibrate them, you use the calibrated data and a complementary filter, and then you should just be getting extremely precise values for your roll and pitch. Okay, now for yaw, you can get the yaw from the magnetometer, right? You can get the yaw from the magnetometer. But what would be even better would be if you would fuse the data from the magnetometer with the z-axis gyro, the rotation about z. So if you take the rotation about z from the gyro and you fuse that with the magnetometer, just like we did accelerometer and gyro, we fuse them with a complementary filter. Now you're going to use a complementary filter to fuse the magnetometer with the z-axis gyro. And then you should sort of have about the ultimate performance that it's possible to get from a $6 sensor. Okay, guys, wow. I hope this wasn't too much for you. Give me feedback. Like I say, the thing that has been the hallmark of this channel is I always have you write your own code, but I kind of felt like I want to get on back to the Arduino side of things. I want to get the SSD 1306 display on here, and I want to start doing things. So I really didn't want to spend another 6 or 7 weeks writing that Python program. I wanted to give it to you. Now you have a good way to calibrate. I have a good way to calibrate. And now we can move forward with our little gizmo here. What's the other good thing? Now that I've got this calibrated function and these calibration parameters in here, I don't have to go back every time to the Python program. They are stored on the Arduino, and now what I have is I have something that they will be there until I want to calibrate it again. Okay, guys, give me feedback on this. This was a really hard one. I'd started down the path of kind of say, okay, well, we started with the magnetometer, but now let's add in the accelerometer. I was just going to kind of pick up where we left off with on that last Python program, but I saw that I was going to have to like rename all my variables as I added the other axes and stuff. I said, this is just going to be too tedious for people. I know that you don't like hour-long videos, and so I thought this was the right way to do it. Give me feedback. Let me know. I'm not going to become a channel that just lets you guys copy and paste, but let me know if it was okay to do it this time. Give me some feedback on this, on this segment of our class, and is it getting old and tedious? You're ready to move on to a different component? Are you eager to go in and get the SSD 1306 on here and start doing some, something that we could operate independently and have a magnetic compass, have an inclinometer, maybe have a bubble level, things like that. Let me know if you've just grown weary of this, or if you still have some energy for this particular part of the class. Okay, guys, I hope you are having as much fun with this class as I am. It's at this point in the program that I always give a big thank you to you guys who are financially supporting me on Patreon. I would not be able to continue to produce fresh, new, in-depth content every single week without the support of my Patreons. Thank you, guys. You can help this video by leaving a comment down below and clicking the like button. If you haven't already, subscribe to the channel, and when you do, make sure you ring that bell so you'll get notification when future lessons drop. And most importantly, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.